Okay, we're going to get started again with our classwork. I'm going to work through a few examples on each page. You guys are going to follow along with me, and then you're going to work on your own. Okay, so this page says simplifying radicals, finding hidden perfect squares and taking their root. Your notes should be helpful with this. This is what we were just doing. Okay, it says simplify each expression by factoring to find perfect squares and then taking their root. So all I'm trying to do is find perfect squares that are evenly divisible. So if I go back to my do now, if I go back here to the do now, I have the first 30 perfect squares, right? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. We're trying to find which perfect squares we can divide that radicand by. Okay, so this first one, it's not divisible by 1, it's not divisible by 4, it's not divisible by 9 or 16, but 25, that one works. So if I do 75 divided by 25, I get 3. So that's the square root of 25 times 3, which is the same thing as the square root of 25 times the square root of 3. And the square root of 25 is 5, so we have 5 root 3. That's how we simplify the square root of 75. Now I have prime numbers, prime factorization. Okay, over here, number 2, well, 16 is a perfect square. If I type in second and the x squared key, and then I type 16 equals into my calculator, I get 4. And I'm just going to jump down here to number 4 because I know 64 is a perfect square. I know that 8 times 8 equals 64. And over here, again, I know that 36 is a perfect square, and 6 times 6 is equal to 6 squared. So the square root of 36 is equal to 6. Okay, over here, oh, we did that one. How about the square root of 80? That is not a perfect square. However, I can take a perfect square out of there. I can divide 80 by 4. Let's try it. 80 divided by 4 equals 20. Well, I can take another perfect square out of there, so I'm going to keep going. I'm going to do 80 divided by 9, oh, that's not a whole number, 80 divided by 16, that gives me 5, so I'm going to do the square root of 16 times 5, and then I'm going to do the square root of 16 times the square root of 5, and the square root of 16 is 4, so my simplified solution, prime factorization, right there, okay, prime numbers under the radical symbol. The square root of 30, this is the last one I'm going to do on this page with you guys. Let's see here. 1, 4, 9, 16, 25. That's as simplified as I can go. I changed my mind. I'm going to do one more. I know that the square root of 8 is equal to the square root of 4 times 2. And I know that the square root of 4 times the square root of 2 is equal to 2 times the square root of 2, because the square root of 4 is 2. So there's the last one right there. At this point, you should pause the video and continue that page. Finish it up on your own. I'm going to go to the next page right now, and we're going to simplify some radicals by adding and subtracting. Simplify radicals by adding and subtracting. That should be page 2, and at the top it gives you some explanation of what you should be doing here. Okay, it says add or subtract radicals by simplifying each term and then combining the like terms. So in the first example, it shows that that 2 root 2 plus the square root of 5 minus 6 root 2 is equal to, well, first thing, square root of 2, square root of 2. I can combine those two values right there. Okay, and remember, when we're adding and subtracting with radicals, the radicand has to be the same, and then you're going to perform the operation on these two. And 2 and negative 6 is negative 4 root 2. That's where this came from right here. And the square root of 5, we can't do anything with that, so that's right there. And that's our final answer. Here are some examples of how that works. Okay, second example says 4 times the square root of 3 minus the square root of 27 is equal to the square root of 4 times the square root of 3 minus the square root of 9 times 3. So they're taking out this perfect square here, right? This is what we just did. The next step shows that 4 times the square root of 3 minus the square root of 9 times the square root of 3 is equivalent to our last expression. And then the square root of 9 is actually 3, so that's where that came from. And then we have a radicand of 3 in both terms, so we can combine our 4 and our negative 3 to get 1 square root of 3. Okay, now I'm going to work through a few examples with you guys. I'm going to look at this first one. Well, first things first, I see that this radicand is the same. So what I'm going to do is combine these terms right here. 3 minus 4 is equal to negative 1 times the square root of 6. So negative square root of 6 is the simplified solution there. Okay, on number 2, again, we have a 7 and a 7. So I can combine my negative 3 and my positive 4. Negative 3 plus 4, that equals 1. And then I just copy the square root of 7. And I can get rid of that 1 because 1 times any number is equal to the number it's multiplied by. I'm going to do a couple more of these with you guys. Okay, I have negative 11 root 21 minus 11 root 21. So I have 2 negative 11s. I'm combining those. So negative 11 minus 11, or negative 11 plus negative 11 equals negative 22, and then I just copy the square root. And I can't factor that out anymore. I can't take anything else out of the square root of 21. I'm going to go over to the next example. Here again, same radicand, so I can combine these coefficients, the negative 9 and the positive 10. And 10 minus 9, or negative 9 plus 10, is 1. Copy the square root of 15, and that's equal to the square root of 15. Okay. So this is adding and subtracting with radicals. You have to make sure the radicand is the same, and then you can combine your terms. Negative 10, positive 12, negative 10, positive 12 equals 2. Copy square root of 7. And you can check your answer, as always, by typing into your calculator both different ways. You can type this into your calculator and type this into your calculator and see what you get. It's going to be the same. They're equivalent, they're equal. And over here we're subtracting, right? We've got 17s there, so I can combine negative 3 and negative 4. Negative 3, negative 4, negative and a negative is negative 7. And the square root of 17. Okay, now I'm going to do one more because on number 8, I can take some values out of this 27. Okay, I have to get my radicands to be the same, and they're not. Okay, but I know that, let's rewrite this, negative 2 root 3 plus the square root of 3 times the square root of, well, 27 is divisible by 9, which is a perfect square. 9 times 3 is 27. Right, all I did was 27 divided by 1, 27 divided by 4, 27 divided by 9. When I got to 9, 27 divided by 9 equals 3. And then I can rewrite it again, negative 2 root 3 plus 3 times square root of 9 times the square root of 3. And I know this is 3 root 3 times 3, and I still have my negative 2 root 3 over here. Okay, now if I multiply my 3 by 3 root 3, I get, I'm just going to go back up over to the top here. I'm going to do negative 2 root 3 plus 9 root 3, because I multiplied these, or I multiplied those first because parentheses, and I got 3 root 3, and then I multiplied 3 root 3 times 3 to get 9 root 3. Now I have the same radicands, and I can combine my positive 9 and my negative 2. Positive 9, negative 2. I can do it just like this if I want to. 9 minus 2 equals 7. And copy the square root of 3. So 7 root 3 is my simplified solution to that problem. Okay, right now you should be finishing this up on your own, looking for perfect squares that you can take out of here. Right, you can take a 4 out of 24, you can take a 9 out of 54. You should pause the video, keep working, finish it up. I'm going to go on to the next page, and I'm going to simplify some radical expressions with multiplication. Okay, again, there's a good explanation at the top of the page what you're supposed to be doing. First, it says multiply both numbers that are outside the radical. So I'm going to highlight all numbers that are outside the radical, symbol 1 color, because those can be multiplied by each other, just identifying like terms. And this is a 1 right here, and this is a 1 right here, and a 4 right there, and negative 1 and positive 1. Okay, and then down here, negative 1. Well, there's a positive 1. There's a 4, and there's a positive 1. I'm going to do a couple more. There's a 1, there's a 1, there's a 1, there's a negative 2. Now I'm going to go back up to top. I'm going to look at that other rule. And the other rule says multiply numbers that are both inside the radical. Now I'm going to highlight everything that's inside a radical. Right, in each equation, I can multiply those values, and those values, and those values. And these ones right here, right here, and right here, and right here. Okay, now I'm going to go back and I'm going to simplify the expressions. 2 times 5 is 10. 2 times 1 is 2, and square root of 5 over here, I can't change much of anything. 5 times 1 is 5 times the square root of 2. In the next example, I can multiply the 2 and the 5. They're both outside the radical symbol, and that gives me 10 times the square root of 3. In the next example, I have 2 times 1 is 2, and 3 times 5 is 15. I can't take anything out of there. 2 times 4, if I go to the next example over here, 2 times 4 is 8, and 3 times 5 is 15. So 8 times the square root of 15. Now back over here. Let's see, 1 times 4, any number times itself is 4, times the square root of 36. Hey, if you're multiplying the square root of 6 by the square root of 6, you get the square root of 36, which is a perfect square, which is equal to 6. So this is actually 4 times 6, which is equal to 24. Over here, I multiply my 1 and my negative 1. Negative 1 and the 5 and the 20 gives me a square root of 100. I multiply a negative times a positive. I should get a negative in the end. The square root of 100 is actually 10. So this is just negative 1 times 10, which is negative 10. All right, there's a few examples there. Now we're multiplying a negative 1 and a positive 1. A negative times a positive is a negative. Times the square root of 2 times 3 is 6. I'm going to move over here. 4 times 1 gives me 4. And then I multiply the green values, square root of 8, and the square root of 2 is the square root of 16. You guys are probably recognizing by this point that the square root of 16 is 4. So that's actually 4 times 4, which is equal to 16. And that's your answer to number 4. Moving on to 5 and 6. In number 5, the numbers outside of the radical symbol are 1 and 1. 1 times 1 is 1. I don't even need that. I'm going to get rid of that. 12 times 15. I'm going to use my calculator. 12 times 15 equals, that's 180. Okay, I know that I can divide 180 by 9. I'm going to try that. 180 divided by 9 equals, that equals 20. Okay, so I know that I can take another perfect square out of there. So now I have the square root of 9 times 20, which is the same thing as the square root of 9 times 4 times 5, right? All these are equivalent expressions. And the square root of 9 times the square root of 4 times the square root of 5 is equal to 3 times 2 times the square root of 5, which equals 6 root 5. A lot of steps to get to the answer in that one. Alright, and one more on this page. The square root of 5 times negative 2 root 5. I multiply my 1 and my negative 2. I get negative 2. And the 5 and the 5, well, that's just going to be 5, like we saw before. It's going to be the square root of 25, which we know is 5. And a negative times a positive is a negative. Don't overthink these sometimes, you guys. That's the last example I'm going to work out with you. You're going to pause the video, finish that page up, and I'm going to go to the next one. Okay, the next one is simplifying radical expressions with division. Okay, dividing and rationalizing the denominator. That means getting the radical symbol out of the denominator. Okay, at the top, it kind of works through some examples to kind of help understand how and why it works this way. Okay, it starts with 6 divided by 3. That equals 2. Okay, and the next one is the square root of 6 divided by the square root of 2. So what we're going to do there is multiply the numerator and the denominator by the square root of 2, which is going to give us the square root of 12 divided by the square root of 4, which is 2. Okay, and the square root of 12 can be simplified even more, right? That's equal to the square root of 4 times the square root of 3. So that's 2 root 3 divided by 2. So the answer there is going to be square root of 4 divided by 2. Those cancel each other out, and we wind up with the square root of 3 as the final answer. Okay, the next example is already rationalized in the denominator. I can't simplify that anymore. That's 1 times the square root of 6 divided by 2. I can't take any other numbers out of 6. I can't factor that any farther. So the square root of 6 divided by 2 is as far as that goes. Over here, I can divide this term by this term and get 6 root 6. Okay. On this side, on the next example, I want to get this radical symbol out of the denominator, and I'm going to do that by multiplying the numerator and the denominator by the square root of 2. Okay, so if I multiply everything by square root of 2, if I say times that, I wind up with 12 times the square root of 12 divided by 2. And then if I take that one step farther, I wind up with 12 divided by 2 being 6 root 12. Now 12 is not factored out. I can take out a perfect square. I can take out a 4. Okay, so that's equal to 6 times the square root of 4 times the square root of 3. And I know that 6 times 2 root 3 is going to be equal to 12 root 3, because 6 times 2 is 12. And that's how we work those things out. Okay, there's some more explanation. Right down here it says simplest form for fractions with a radical symbol. No perfect square factor under a radical symbol. Okay, it gives an example. We've already worked this one out. The square root of 75 is equal to the square root of 25 times the square root of 3, which is equal to 5 times the square root of 3. We also can't have fractions under a radical symbol. Okay, square root of 3 divided by the square root of 4 is equal to the square root of 3 divided by the square root of 4, which is equal to the square root of 3 divided by 2. Okay, we can't have a radical symbol in the denominator. If there's a radical symbol in the denominator, we need to get rid of it. Okay, if we start with 2 divided by the square root of 3 like we did earlier, like we did in the examples in the notes. We multiplied the numerator and the denominator by the denominator, and we got 2 times the square root of 3 is equal to the square root of 9, which is equal to 2 times the square root of 3 divided by 3, because the square root of 9 is 3. We got the radical symbol out of the denominator that way. And then you must reduce everything always. If you can reduce the fraction, you must do it. Okay, like I just showed you earlier, the 8 and the 2, they can be divided. 8 divided by 2 is 4. That's where that comes from right there. Okay, let's work through a few examples together. So number 11 says the square root of 8 divided by the square root of 7. Okay, I have a radical symbol in the denominator. So look at rule 3 right there. What we did was multiply the numerator and the denominator by the denominator, right? Because we're multiplying by 1. We're not changing the value of it at all. And that's going to give me the square root of 56 divided by square root of 49, which is 7. Now, 56, can I reduce that at all? Is that divisible by 1, 4, 9, 16, 25, 36? Let's try it. 56 divided by 4 equals 14. Okay, so this is equal to the square root of 4 times 14 divided by 7. Okay, the next step is the square root of 4 times the square root of 14 divided by 7. The square root of 4 is 2, so we have 2 times the square root of 14. I'll come back over here. 2 times the square root of 14 divided by 7. 2/7 is reduced to lowest terms, and 14 cannot be factored out anymore. Okay. Now we're going to go on to number 12. Number 12 has a radical symbol in the denominator. It says no radical in the denominator, so I'm going to multiply. I'm going to multiply just like I did. And that's going to give me 7 root 7, because I multiply the numbers that are outside. A 7 and a 1, 7 times 1 is 7 right there. And the numbers that are inside, there's only a square root of 7. And then in the denominator, I do the same thing. 8 times the square root of 7 times the square root of 7. And the square root of 7 times the square root of 7 is 7 times 8 is 56. Now I know that 56 is divisible by 7. Okay, so 56 divided by 7 equals 8. So I have 1 root 7 over 8. And the only thing left to do is get rid of that 1. So it's equal to the square root of 7 divided by 8. Final answer, number 12. I'm going to work out a couple more of these with you, and then we're going to wrap it up. Okay, I'm going to look back at those rules. Hey, I can't have a radical sign in the denominator. I'm trying to get rid of that. So I'm going to do this again. And that's going to be equal to the square root of 12 divided by 6. Because again, the square root of 6 times the square root of 6 equals the square root of 36, which equals 6. So that's my new denominator. And 12 can be factored out, right? 12 is equal to the square root of 4 times the square root of 3. And the square root of 4 is 2, so that's where that comes from. 2 root 3 divided by 6. And I know that 2 divided by 6, or 6 is divisible by 2, and I wind up with 3 in the denominator, so the square root of 3 divided by 3 is my final answer there. Okay, and over here, number 14, let's see, I've got a radical symbol in the denominator, so I'm going to get rid of that thing. I'm going to multiply by 15 up here, and I'm going to multiply by 15 down here, and that equals, what's 21 times 15? That's 315. So now I have the square root of 315 divided by 15. Now I'm going to guess that 315 is divisible by a perfect square. So I'm going to do 315 divided by 9. Let's try that one. 35. So the square root of 35 times the square root of 9 divided by 15. And I know that the square root of 9 is 3, so now I have 3 root 35 divided by 15. And 35 is not divisible by any perfect squares, so all I'm going to do is divide these numbers here. They're outside of the radical symbol and wind up with 1 over 5 root 35. And that 1 is not essential, so we're going to get rid of that. I'm probably writing a little bit more than I have to, but those are all the steps to get there. Okay, that's 11 through 14. And what I would like you to do is finish up 15, 16, 17, and 18. And I'm going to stop right there.